So what we're doing were problems where we're looking for a missing side. Now we're going to be looking for a missing angle. So whenever you come across a problem and you're looking for a missing angle, that should immediately red flags, fireworks, warning signs, whatever it is in your head that happens when you go, yes, that means I have to do this. You should immediately think of the inverse trig functions. So here's the idea. Uh, Sine of some unknown angle is root 2 over 2. Now, you may be able to recognize some of these as some of our 30, 45, or 60 angle measures. And we just talked about this one in the last video. Sine of 45 is root 2 over 2. So we know this theta is supposed to be 45 degrees, but how do we calculate that out? Well, what we do is we use the inverse trig function. So normally you plug an angle into a trig function and you get out a ratio. So the domain is an angle, the range is a ratio. Now, for the inverse sine of root 2 over 2, the domain is a ratio, and the ratio usually has to be between 0 and 1, unless you're working with tangent, or negative 1 and 1, but that's a different time. And the range is going to be an angle. That means we're going to put in a ratio, and out pops an angle. And so we should expect to have 45 degrees. And this is another thing where it's very, very important to make sure that you're set on degrees. The way I get to it, if you take a look above your buttons here, here we have a sine, a cosine, and a tangent. That stands for arc sine, arc cosine, and arc tangent, ARC. It's the same thing as inverse sine. So if I hit shift, I hit arc sine, and then type in the square root of 2, get out of the square root, divided by 2, and hit execute, and it gives us 45 degrees. So that, I guess that's a good thing here. Sine inverse of an angle is equal to a sine. That was 45 degrees. The way you read that is just arc sine. Whatever trig function it is, just arc whatever it is. Some calculators will have the actual inverse sine. I think that's what our blue calculators have. Some will have the arc sine. Either one works. All right, let's actually use this in a couple examples here. You can see on our examples, we're trying to find a missing angle measure. And in particular, they want us to round to the nearest tenth, if we have to do any rounding at all. So very important in all of these is to figure out where you're standing. And they'll tell you that in the directions. Ooh, stand at angle N. That's over here. That's where I'm standing. If I take a look, I have the hypotenuse, which is always opposite the right angle, and I have the opposite side. Opposite and hypotenuse, that is the sine of angle N is equal to the opposite over the hypotenuse. Now what's interesting here is we usually don't write sine of angle N in it. This is why we usually use theta and gamma and beta and all and phi and all those things, because we don't like to write the angle symbol in the middle. Like writing sine angle N is kind of a pain in the butt, because then all of a sudden it gets confused with inequalities. We just don't like to do it. So usually you can leave the symbol out there until you take the inverse sine of that ratio, and then you throw back down the measure of angle N. You can also just leave it as capital N. I'm not going to worry about it too much. One nice thing here is I don't need to reduce that ratio down. If you remember, I could scroll up to it real quick if I wanted to make you dizzy. But if you go back, I think it was in the second video, we're talking about how there was the triangle with 350 over 700. It doesn't matter the size of the sides. That ratio is what we want. So whether it's 6 over 10, 3 over 5, 60 over 100, it doesn't matter. 36 over 60, the ratio is always going to be the same. So we just type that into our calculator. Arcsine of 6 divided by 10. Execute. We get 36.8699. So that's approximately 36.86, and it said round to the nearest tenth, so I round that up. So measure of angle N is equal to 36.9 degrees. Do pay attention to how far they tell you to round it. Some problems will just round it to the nearest angle, some want to the nearest tenth, some want more. Okay, part B. Same kind of problem. We're looking for an angle. It tells us it's angle B. So now I'm standing down here at angle B. I notice I got the adjacent side, and I got the hypotenuse. Well, that tells me cosine of that angle B is equal to the adjacent, 8 over 16. And cosine of B equals, well, this is where reducing things sometimes helps. 8 over 16 is 1/2, isn't it? Maybe that was one of the 30, 45, or 60 angles. If you go back up or turn to the page, was it 791? Yeah, 791. I see 1/2. Anyone? Cosine of 1/2 is 60 degrees. Oh, there we go. I don't even need to plug it in my calculator. I know the only angle that makes this true is if B is 60 degrees. Now, if you don't believe that, let's go ahead and plug it into our calculator. Use inverse cosine of 1/2. You could type in 8/16 if you want to. That's going to be the measure of angle B. Arc cosine, 1/2. Execute, 60 degrees. All right. So it worked. That was what we expected, right? So that's another thing that's nice about those tables. Even just getting it to the point where we recognize 1/2, root 2 over 2, root 3 over 3, root 3 over 2, those things all have some sort of relationships with each other. Then that'll make your life a little bit easier, because you know that's going to be 45, 60, 30, right? Those are pretty common ones.